Section 9.4, rational expressions. In this section, we're going to simplify some rational expressions and also talk about how to multiply and divide them. So we're going to need a few of our previous skills, one of those being factoring polynomials, and the second being working with fractions and how we work with. So let's start with a rational expression. Now, a rational expression is defined as an expression that can be written as a quotient of two polynomials. So if you remember, polynomials can be anything from monomials to like a binomial or a trinomial or any other kind of polynomial. So an example that we might have of what makes a polynomial is that maybe we might have something like, let's do some quadratics. X squared plus 3x minus 6 over maybe something like 2x squared plus 5x minus 9. Okay, anything that creates a polynomial all over a polynomial. And in simplest form, a rational expression is when the numerator and denominator do not have any common factors remaining. So we want to take out all those common factors and put it into simplest form. All right, so to do that, like I said, one of the skills we have to remember is our factoring. In order to do any canceling or any reducing, we can only cancel things that are factors. And in my example, if I leave them in this format, none of these things are factors. They're terms. When you add and subtract them, they make terms. So x squared is a term, 10x a term, and 25 is a term. I need to factor the numerator and the denominator if possible so that I can actually get those factors and cancel. So let's do that. If you remember how to factor a quadratic, a trinomial will typically factor into a set of binomials. So we're going to factor the numerator, x. Looks like I have positive 25 with positive 10 in the middle, so plus and plus. Factors of 25 that I could use to get 10, 5 and 5. Okay, then I repeat the process for the denominator as well. It's also a trinomial quadratic. Okay, and then plus and plus for this one this time. Factors of 20 that give me 9, how about 4 and 5? Now, we talked about this previously when we divided functions, that if you have variables in the denominator of your problem, you're going to have restrictions, which just simply means that there are certain values that we cannot use in this expression because it would make the expression undefined. And if you remember that, that is when your denominator cannot equal 0 because you can't divide by 0. It's undefined. So we can real quick figure that out by looking at our denominator here, which has two factors in it, has both the x plus 4 and the x plus 5. So if you want to find restrictions, you take each of those factors. You don't want them to be 0, so we'll say it does not equal 0, and we'll say that x cannot equal negative 4, and x cannot equal negative 5. So those would be my restrictions, and you want to do that with the original problem, not just your finished product or your finished expression. All right, so then it says divide out the common factors. In other words, we want to cancel whatever they have in common. So to do that canceling, if you look up here, the factors are these whole binomials. So the only factors that I can cancel out would be one set of x plus 5s. So when I have what's left, okay, I happen to have an x plus 5 in my numerator. So we'll put x plus 5 over, in my denominator, I still have x plus 4. So to keep this true to the original problem, though, I also, even though one of those canceled out, I need to keep my restrictions, both of them, and then there's my simplified version of my rational expression, x plus 5 over x plus 4. Okay, so here's some that you're going to try. We're going to work these out as examples in class, looking at the different ways that we can do some factoring. You can try them on your own before you come if you want to see how you feel about the way we work these, but we're going to do these as examples in class. let's move on to the multiplication. The nice thing is that once you get the simplifying down, the multiplying part is pretty much like the simplifying. You just have more than one fraction of polynomials to work with here. So just like any other type of fractions that you're multiplying, you can cancel any part of any numerator with any part of any denominator. Again, just making sure that you have factors here, not just terms, right? So right now they're terms. We want to check them for factors. So I'm going to start with my numerator here, and I'll just work my way through factoring everything, and then we'll see what we can divide out or cancel out. So let's start with this numerator here. Whoops. In this numerator, 2x squared plus 7x plus 3, I need to figure out how to make the binomials to get a 7 in the middle. So I think how I'm going to do that, I'm going to go with, for the 2x squared, I'll have to do 2x and an x. Everything's going to be plus. And I think for the factors of 3, since it's just 1 and 3, I'm going to do this, 1 and 3. That way I get 6x from the 2 and the 3, and a 1x, and then that makes a 7 in the middle. Now the x minus 4 in the denominator, that's just a linear term, or factor, so we'll just leave that. Okay, multiplying, x squared minus 16, that's a difference of 2 squares, so x plus minus square root of 16 is 4. So we'll go 4 and 4. Do my binomials for this denominator, x plus and plus for everything. Factors of 15 to give me 8 in the middle, 5 and 3. All right, so real quick, let's make a note of our restrictions before we move on. I'm going to say x cannot equal, if you look at your denominators here, I'm going to say positive 4, probably negative 5, and negative 3. Okay, those would be the values that would end up making a 0 in those denominators. So I'm going to go with 4, negative 5, and negative 3. All right, so let's finish this up. Let's do the canceling. So what I see that I can cancel is I see an x minus 4 that can cancel. Remember, any denominator with any numerator. I see an x plus 3 that can cancel. And other than that, I believe that's it. So what I have left, when it says combine the remaining factors, I have a 2x plus 1. I have an x plus 4. And in the denominator, I have left x plus 5. So when I say combine them, what do I need to do to my numerator to get those actually multiplied together? Okay, well, I need to do FOIL. So if I do FOIL, I'm going to end up with 2x squared. Then I'll have an 8x and a 1x, so I'll get a 9x. And then 4 times 1 gives me 4. And then the denominator is still just x plus 5. So not only do I have that, but I have my restrictions from my original problem, and that would be my final answer. Okay, so now dividing. The only difference that we have to do with division, if you remember fractions, to divide fractions, you're actually going to change the division to multiplying by the reciprocal. Remember, most of you probably remember it, flip it and multiply. So you're going to flip the second fraction and you're going to multiply that, or do it all like multiplication we did previously. Now, this particular problem, I kind of helped us out a little bit. I did most all of the factoring here for you, because I just wanted to kind of show you the dividing part of it, not really so much the factoring. So I've already factored it out. The only exception would maybe be this right here. And the reason is, you'll notice all my other binomials, the x comes first. And on this, you know, if it was addition, it wouldn't matter. X minus 4 and 4 minus x would be the same if you were doing addition. But for subtraction, they're a little bit different. So I can actually do a little bit of factoring and make that 4 minus x into x minus 4. If I simply take out a negative 1, the x and the 4 become their opposites. So I can actually switch it back around to x minus 4 instead of 4 minus x. So rules of division of fractions. You take the first fraction and you keep it the way it is. Okay, so we're not changing that one. Again, I've already done the multiplying for you. or sorry, the factoring for you. And then the second fraction, however, though, I need to flip it. So what's in the denominator goes to the numerator and numerator to denominator. So it ends up looking like this: x minus 2 and 7x minus 5. And then the denominator is 5x minus 4. Now, I do need to make sure that when I do my restrictions, not only do I use all the things in my original denominators as restrictions, but that if there's anything else when I flip my fractions over that also ends up in the denominator, I need to make sure I include that as well. Okay, so if you want to stop at this point and do your restrictions would be, let's see, for 3x minus 2, that's going to be 2/3. If you need to, you can write out and solve these equations. The second one is going to be positive 2. This would also be positive 2. This one would be a positive 5/7, so 5/7. And then lastly, this new denominator down here after I flipped my fraction over, after I did the reciprocal, is going to be a positive 4. So those are all my restrictions on my variables. Now let's go ahead and do our canceling. So you'll notice again, any denominator with any numerator. So I see x minus 4 that can cancel, x minus 2 that can cancel, and that's pretty much it. So it leaves me with, in my numerator, a negative 1 times 7x minus 5. And in my denominator, I have a 5 and a 3x minus 2. So if I actually end up multiplying that all together, negative 7x plus 5 over 15x minus 10. Okay, so I got all my restrictions and my rational expression that is simplified. Okay, so again, you have these two problems that we're going to try in class, but if you, like I said, want to give it a shot before you head to class so you can have some questions ready, that would be perfect.